tonight's notes are going to be on embedded triangles. And this will be on page 18. So embedded triangles, page 18. Now, embedded. That's kind of a weird word. Let's talk about what that word means. Embedded just means put inside or put together, okay? So what embedded triangles look like is if we have a triangle, but then we have another triangle inside. So technically there are two triangles here. We have this little triangle here and this bigger triangle here, okay? Now, these triangles are similar, but let's talk about why. Well, those lines are parallel, okay? So let's write down why are, that's not how to spell embedded. Why are embedded triangles similar? So we're going to prove that these are similar, okay? So I have these two triangles. Now it's kind of hard to see when they're drawn like this. So the first thing I always like to do is redraw them as two triangles. So I'm going to take this little triangle and let's put that, I'm going to highlight it in yellow. So this triangle right here, this little guy, I'm going to redraw it so I have this triangle. And then I'm going to redraw the other one, let's say in this teal color, and that's going to be this big triangle. And I always suggest that when you have embedded triangles that you just redraw them because it's easier to see things when they're redrawn. So first off, this angle in this yellow triangle is right here. Well, it's also right here. So those angles are congruent because they are the same. So I wrote, the angles are congruent because they are the same angle, right? I just took that angle and it's right there and it's also right there. Okay, those are congruent because they're the same angle. And then the other thing we can look at is, well, we have parallel lines and we know lots of things about parallel lines. So let's look at this for a second. If I have these parallel lines, I'm gonna go like this so you can see what I'm talking about, and like this. So those are my parallel lines. Now I can extend those parallel lines so they go like this. Now looking at that, I have a transversal here. I have parallel lines cut by a transversal. Now whenever you have parallel lines cut by a transversal, we know lots of different things about the angles. But looking at this parallel line cut by the transversal, this angle and this angle have something in common. What kind of angles are those when you have two parallel lines cut by a transversal? Hopefully you said that those are corresponding. So those angles right here are corresponding angles. They're corresponding angles, which means they are congruent. Now, going back to our similarity reasons, we have congruent angles. So by angle, those triangles are similar. And why is that important? Why is it important that those triangles are similar? Well, once we have similar triangles, then we know that the sides are proportional and we can solve for side lengths. And that's exactly what we're going to be doing in these notes, is we're going to be solving for side lengths now that we know that those triangles are similar. Okay, so let's start off with an example. Just like in that first picture, we're going to have a triangle and we're going to have embedded triangles. And let's just go ahead and label these A, B, C, D, E. We know we have parallel lines. And then I'm going to give you that AB is 4, BD is 10, BC is 6, and I want you to find DE. Okay? So let's put these values on our picture to start. Well, we have AB, 4, BD is 10, and BC is 6. And I don't know DE, so I'm going to call it X because I don't know that one. Okay? Now, just like before, I put some asterisks. I said redraw as two triangles. That's definitely how I want you to start. So we're going to redraw this as two triangles. My first triangle is going to be the small one. And that was ABC. And then we also need those values on there. So we had 4 and we have 6. Then I'm going to draw the big triangle. And the top is A, the bottom of the big triangle is D, and then E. So that big triangle is ADE. And remember, we already proved that they're similar, right? We have angle, angle. So they are similar, so that means we do have proportion. We have proportional sides. Okay? Now DE we don't know is X, but AD, okay, so if we look at AD, what is the full length of AD? It is 14, because we go all the way from 4 and then to 10, so that's 14. Okay, now from here we can use our scale factor, right? We know that since they're proportional, we have to go 4 times something is going to be 14. Let's actually call that Y so it doesn't get confused with that X. So 4 times something has to be 14, divide by 4, which means our scale factor is going to be 14 over 4. That's the scale factor. To do this problem, you could have found the scale factor or you could have done proportions. It doesn't matter, you will get the same answer. Then we're going to do the same scale factor to find X. So that means we're going to multiply by 14 over 4. So we're going to do 6 times 14 over 4. And that's a really hard problem, so I'm just going to put it right in my calculator. 6 times 14 over 4, it's 21. So that means our X is 21. Okay, like I said, you could have done proportions if that's how your teacher teaches it, but I'm going to do scale factor, which means I'm just solving for that scale factor and using it again. Okay? Now I'm going to have you do an example before I go over it. So this is going to be your first example doing this by yourselves. Okay, so I actually am going to have you solve for X and Y this time. So there's 2 different variables you're going to need to solve for. Again, my hint to you is to draw 2 separate triangles. So hopefully you've already done that. Now let's go ahead and draw 2 separate triangles. So this is triangle A, B, C. We have 15, 10, and 12 on the side lengths. Then in the bigger triangle, I don't have a ton of room, so it may not look that big, but it is the big triangle. A, D, E. This whole side length is 15 plus 6, because we have the whole side length, 15 plus 6, 21. Ooh, this side length is a little bit trickier. That's 12 plus y, because it's that whole thing. And this guy is x. So, again, I'm going to use scale factor. This is going to be 15 times something, let's call it z, is going to give me 21. So 15z equals 21. Divide by that 15. So that means our scale factor is 21 over 15. I'm going to use that to find my x, 21 over 15. So 10 times 21 over 15 equals, again, put that right in my calculator, times 21 over 15, 14. So this is 14. And then that last one. Well, if I multiply by 21 over 15 to 12, that's not going to give me that value. Oh, wait. Yeah, it will. Let's try that. Sorry. Let's do 12 times 21 over 15. And again, I don't have a ton of room, but 12 times 21 over 15 equals 16.8. Okay? Now, think about this to yourselves. How can I use that 16.8 to figure out what y is? Well, I can say that this whole thing has to be 16.8, so that means it has to be 12 plus y, which means y has to equal 4.8. And that's how we solve for y. But you could have used proportions. Maybe proportions would have been easier in this time. I don't know. Whatever you prefer.